My name is Alberto Yuc-Lafuente and I work at the Technical University of Denmark. In this video I will share with you current research we are doing within the Europeans project CyberSec for Europe in the area of threat modeling and assessment. In particular, I will provide a brief demo of a tool called Risqflan. So let's move to the demo. I will open this file. It is a tool for threat modeling using attack defense trees. It is based on Eclipse technologies, as you perhaps will recognize. Here I have to select a workspace. You will see many familiar things if you are used to Eclipse. In particular, you will see views like, for example, the Project Explorer. You will see views like an outline of the project, but let us start it from scratch. I will show you how it looks, for example, if we want to create a new project. So I can select new Risqflan project. I can give it a name. Let's say we want to call it Hello World. Finish. I'm offered to change perspective. I will say no. Once we have a project, we can start populating it with models. These are called Risqflan files. And I can create a new file here, hello world. And I think we have here is that you can select an initial template, so you can start from scratch or use some template that will help you a bit, having a bit of structure and then to refine it. Yes, of course, I want to adopt the Risqflan perspective. So it's basically what you get, a sort of template where you can fill all these modules, these blocks that we have in this domain-specific language for threat modeling with attack trees. And you get also, in addition to this file, some visualization of what you are starting to model. So this is basically what we have here, a very simple attack tree. It has two attack nodes, a root and a sub attack. But let's get rid of all of this. Let's say that now we want to do something more specific related to an interesting scenario like a traffic control system. And let's say that the worst thing that can happen here is that the traffic control system gets compromised. Traffic system compromised. And as you see, we can use Eclipse-based editor features like refactoring using renaming. So we don't need to go and replace every occurrence manually. I can, for example, say that, okay, for the attack system to be compromised, perhaps the sensor data, one of the things that can happen is that the sensor data gets compromised. And you see, when we do this kind of these changes, also our graphical view will change. Let us open it. Yes, okay. I forgot to save here. Let us open it again, and now we see how we have changed the attack tree to be more focused on the scenario that we are interested in. Let us make it a bit more interesting. Let's say that we know that sensor data can get compromised whenever some attacker enacts one of these known vulnerabilities, like let's say 770, which is about allocation of resources without limits. And what we need to do in this language is not only to specify these bad things that can happen, the attack nodes, but of course how they relate to each other. And you see here how these two vulnerabilities relate to each other. So it's something we can try to do again. So we can write here that the sensor data can get compromised if, for example, the attacker enacts this vulnerability that we mentioned before. Okay. So again, we can see, let me remove the console, we can see how it looks, and this is what we are doing. So we can keep constructing this tree and splitting down the problem into smaller problems, let's say. That's the way we would do threat modeling using attack trees. Another thing we can do is also we can introduce defenses. So there is a block for that. We can also have defensive nodes. And let's say that the kind of defense we want to consider against this vulnerability is to track and block a request. So we try to mitigate the fact that an attacker can say compromise the data by just making a lot of requests. Okay, so this is a new defense that we have. If we look at the visual representation here, the defense is hanging around. This is not good. We have to specify to which vulnerability acts as a countermeasure, and this is something we can do with the same kind of language features. So we can write here, oh, actually this vulnerability here 770, it's has a countermeasure, which is this track and block request. Okay, so if we now have a look, we see now the defense is in the right place, is under the corresponding vulnerability. And there are many more features that we can specify in this attack tree model, of course, many more defenses and attacks and how they relate to each other. But we can also introduce things like specify the effectiveness of defenses against particular vulnerabilities. So I can write here, for example, that this defense here, track and block request, when it works against all sorts of attackers. We could be more specific and specify particular profiles of attackers that say we now want to specify how it works against all kinds of attackers when they try to exploit this vulnerability. It will have an efficiency of, let's say, 0.9. Okay, it's just an arbitrary number that I'm putting there, and then this will be also reflected in the graphical representation here. All these numerical quantities that we can have. You can also add cost. What is the cost of each of the actions, the defenses, or the attacks, and etc. etc. So it's a very rich language to specify a threat model. I will stop here giving you the overview of the language because it's really a very rich language. What I will show you now is how it looks when you are done with a bit more complex scenario, and this is the one we are modeling in CyberSec for Europe. And yes, this is the long piece of text that specifies everything, and this is how it looks graphically. I can show you perhaps here the entire attack tree that we have developed. This and you can also see it in more, let's say, you can zoom and you can navigate and see, and you can agree or disagree with all these ways of splitting down the problem of the compromising the traffic system and the defenses and whatnot. And at some point, let's say when you are happy with your threat model, there are several things that you can do. These things in our tool are specified at the end of the specification of the threat model, so you can specify things like I want to simulate, this is out-commented, or I want to perform some statistical analysis and get some results. And another thing, and the thing that the feature that I would like to demo now is that you can export these models in some formats that you can then process with other tools. So in this case, I'm exporting the threat model as a stochastic model, and then I will use a stochastic model checker to do some precise stochastic analysis. Good. So basically what happens is that when I click here, so when I click here on this button, I will get this executed. So basically I will get this file here, which I can open. I can open here inside or just with my default editor. That could be, for example, Atom in my case. And I get this piece of text here. You see that is the model, my thread model, but in the format of the tool I'm going to use. Then I can copy this, open my favorite model checker like Prism, and I can just copy the thing here and start working with it and doing some analysis. So this is some analysis I have already done. This is basically the analysis of the probability that the traffic system gets compromised as an attacker gets more and more opportunities. So in the y-axis you have the probability, and the x-axis you will get the number of attempts that the number of chances that the attacker is allowed to have. This is the final result. Let me show you what happens if I, for example, use the tool here, the Prism model checker, and perform this kind of analysis. Yes, okay. I will get our Prince will start doing the analysis for this model for several number of steps, and while it is thinking, perhaps I can show you here what is going to be the final result. So basically, the probability will increase as the attacker has more and more chances, but at some point it will converge to some value. And this is basically because in the model we have considered, even if I didn't tell you that, maybe I can show you in detail here, that some of these attacks have some cost, some monetary cost, and I have put a bound on them. So it seems that Prince is already working here. You see it's computing the probability for each of the points on time, and it will construct this very nice plot slowly, but at some point you will see that this curve that now is going linearly up at some point will converge to 0.7. Okay. So if you want to know more about all this, please have a look at this deliverable from CyberSec for Europe, deliverable D3.15. It will be available on the webpage of CyberSec for Europe. But in general, if you want to know more about this research and this tool, please don't hesitate to send me an email at this email address. Thanks a lot. See you.